Now let's look into Kubernetes high-level architecture. So a Kubernetes cluster consists of a set of worker machines called nodes that run containerized applications. Every cluster has at least one worker node. So in this example, we have a cluster of three machines, and out of which one is a master node or control plane, and second one is a node or working node, and the third one is working node or node. So that means this cluster consists of one master node and two working nodes. So the worker nodes host the pods that are the components of the application workload. The control plane manages the worker nodes and the pods in the cluster. In production environments, the control plane usually runs across multiple computers and a cluster usually runs multiple nodes, providing fault tolerance and high availability. Then let's look into the node components. Node components run on every node, maintaining running pods and providing the Kubernetes runtime environment. The nodes are bare metal servers or on-premises VMs or VMs on a cloud provider. The nodes could be anything. So we have three nodes. Out of these three nodes, this node could be a bare metal server or on-premise VM or virtual machine or VMs on a cloud provider. It could be anything, but a node means a simple host machine, a simple virtual machine, or a easy to instance in AWS. It could be an instance or virtual machine in Google Cloud Provider, or it could be a machine in Microsoft Azure. Okay, so every node contains a container runtime environment. So in this case, a Docker. For our example, we are using a Docker engine. That is our container runtime environment. So the container runtime is the software that is responsible for running containers. Kubernetes supports container runtime. Kubernetes supports container runtimes such as a containered CRI-O and any other implementations of Kubernetes CRI, that is container runtime interface. Then another component that we find in working node is kubelet. A kubelet is responsible for starting, stopping, and managing individual containers by requests from the Kubernetes control plane. As an agent that runs on each node in the cluster, it makes sure that the containers are running in a pod. The kubelet takes a set of pod specs that are provided through various mechanisms and ensures that the containers described in those pod specs are running and healthy. The kubelet does not manage containers which are not created by Kubernetes. Then the third component that we can find inside a working node is a kube proxy or just a proxy. A kube proxy, here it is, you can see that it's flickering. A kube proxy is responsible for networking and load balancing. It's fundamentally responsible for networking and load balancing, and this is the only component that takes care of networking and load balancing. So kube proxy is a network proxy that runs on each node in your cluster and implementing part of the Kubernetes service concept. And kubeproxy maintains network rules on nodes. So these network rules allow network communication to your ports from network sessions inside or outside of your cluster. And kubeproxy uses the operating system packet filtering layer if there is one and it's available. Otherwise, kubeproxy forwards the traffic itself. So that's how a kubeproxy is absolutely takes care of networking and load balancing inside a working node. So these are the main three components that we have seen in working node. It's the first one is a Docker or container runtime environment, a kubelet, and a proxy. A kubelet is actual one which is responsible for starting, stopping, and maintaining individual containers by request from the Kubernetes control plane, whereas the proxy is responsible for networking and load balancing, whereas a Docker is the one, a container runtime environment which receives commands from the kubelet and it starts up pods, and inside that pods you will find your containers. On the left side, we have the most important one, that is master node or control plane. Master node or control plane. So a Kubernetes cluster also contains one or more master nodes that run the Kubernetes control plane. The control plane consists of different processes. The control plane's components make global decisions about the cluster, for example, scheduling, as well as detecting and responding to cluster events. For example, starting up a new pod when a deployment's replicas field is unsatisfied. Control plane components can be run on any machine in the cluster. However, for simplicity, setup scripts typically start all control plane components on the same machine and do not run user containers on the machine. So we have such as an API server provides JSON over HTTP API. So the API server is a component of the Kubernetes control plane that exposes the Kubernetes API. The API server is the front end for the Kubernetes control plane. The main implementation of a Kubernetes API server is Kube API server. A Kube-API server is designed to scale horizontally. That is, it scales by deploying more instances. You can run several instances of Kube server and balance traffic between those instances. Then the second component that we have in control plane is scheduler. Scheduler, it selects nodes to run containers. control plane component that watches for newly created pods with no assigned nodes and selected node for them to run on. Factors taken into account for scheduling decisions include individual and collective resource requirements, hardware, software policy constraints, affinity and anti-affinity specifications, data locally, inter-workload interface, and deadlines. So then the third component that we have here is controller manager. Controller manager runs controllers. So control plane component that runs controller processes, and logically each controller is a separate process, but to reduce complexity they are compiled into a single binary and run in a single process. So controller some types of these controllers are node controller, job controller, endpoint slice, service count, and service account. So node controller responsible for noticing and responding when nodes go down, and job controller watches for job objects that represent one of tasks, then create pods to run those tasks to completion. Then endpoint slice controller populates endpoint slice objects to provide a link between services and pods, and service account controller creates default service accounts for new namespaces. Then the fourth component that we have here is etcd. So etcd, a globally available configuration store. So etcd is a consistent and highly available key value store used as a Kubernetes backing store for all cluster data. If your Kubernetes cluster uses etcd as its backing store, make sure you have a backup plan for those data. So these are the main components of control plane. So control plane consists of a scheduler, API server, control manager or controller manager, and etcd. And again, there are four types of specific controller are there in controller manager: node controller, job controller, endpoint slice controller, service account controller. And finally, we have a etcd, which stores a key value pairs as a key value pairs concept to store the data. That's like backing store for all cluster data. Then finally, we have kubectl, the CLI dashboard, and CLI command line interface. The Kubernetes command line interface, that's a kubectl. A Kubernetes cluster can be managed via the Kubernetes dashboard or a web UI user interface running on the master node. The cluster can also be managed the cluster can also be managed via the command line tool called kubectl, which can be installed on any machine able to access the API server running on master node. So this tool can be used to manage several Kubernetes clusters by specifying a context defined in a configuration file. So this is the high level sneak peek into a Kubernetes architecture. A Kubernetes architecture is nothing but we will look into the cluster first. So the cluster consists of a master node or control plane, that is one host, and other than that you will have a working nodes in that, and working nodes consists of a Docker container, runtime engine, and kubelet and proxy, whereas master node or control plane consists of API server, scheduler, controller manager, and etcd.